All right, and I'll just mention, we love these to be interactive, so please feel free, to go on camera if you're on Zoom, unmute, ask questions. You can always type your questions into chat as well, both if you're on LinkedIn streaming or Zoom. I'll be monitoring those and make sure we get those questions answered. All right. Thanks, Brian.
All right, thank you. Hi, everyone. So today I'm going to be talking to you about the ongoing work with the Arrow Flight connector that we are adding to Presto. I'll give an overview about what it is and what it brings to Presto. I'll go through an example so we can see how the different parts interact with each other. And we'll talk about some of the things you need to keep in mind if you're making your own implementation of a flight connector. So first, just a little bit about me. My name is Brian Cutler. I'm a software engineer at IBM, and I've worked in open source software on and off for a number of years now. I've been a part of a few different projects in the past, including Apache Arrow and Apache Spark. And most recently, I've been contributing to the Presto project, and it's a great community, and I'm really happy to be a part of this project. So, all right. The main goal of Arrow Flight Connector and Presto is to provide a base template for Presto users so they can implement their own custom flight connector to connect to different data sources. This goes back to a Presto RFC, the 004 in the link there. And you can take a look. It has a lot of good details about the design and use cases. So the current status of this is the Java portion connector of the connector has been merged as of February 5th. The native connector is still an ongoing pull request. It's in review, but it's nearly complete. So I have a feeling we'll be merging that very soon. I'll start off with just a quick overview of what Apache Arrow is and the basics in case people aren't familiar with that. So the core of Apache Arrow is to define an in-memory columnar data format. This format is language agnostic, which means it doesn't require a specific language, but there are implementations in all the major languages and more. So you have a Java, C++, and Python implementations. The APIs are not necessarily the same, but the important part is the data format all is exactly the same. And when I say that it's an in-memory format, it's different than a file format. So it's really designed to be an in-memory data structures for efficient use in analytics and allows you to do things like operate with SIMD operations and zero copy to quickly and efficiently exchange the Arrow data between systems. And so it's not really designed to be like a long-term file format storage. There's plenty of other formats for that. Now, Flight is built on top of Arrow, and what that is a protocol that's designed to transmit Arrow data over the wire. So you can think of this as like a connection of remote procedure calls that allow you to do the kind of standard things you'd want to do to connect to remote data sources. So things like metadata retrieval, streaming record batches, making calls to custom actions to do different commands. One good benefit is that it allows you to read batches of data in parallel. That's very useful for something like Presto and other distributed systems. It uses gRPC as kind of the default out-of-the-box transport, but it's not necessarily tied to that, but that is the most convenient transport to use. Okay. All right, so when we talk about the flight connector in Presto, what we're actually providing is a base template that you can use as sort of like a library to make your own concrete implementation. So with just some minimal code, you can build on top of this to have your own implementation work with whatever flight service you're using. So the template library that's provided, it's not bound to any specific exact flight service. That part is left open, and that's the portion that you'll need to implement. So all the hard part has been done already. The flight client is provided within the connector, data conversion. So you're really just kind of connecting some pipes to get the thing working with your own flight service. As you can see from this diagram, you have your Presto cluster on the left, flight service in the middle, and the data sources, different data sources to the right. So what this layout does is the data sources are now decoupled from Presto. So the flight connector interacts with the flight service, and your flight service interacts with the data sources. So uh, the data sources are not tied to Presto directly, and provides this kind of intermediate layer. So why would we introduce this and not just add more direct connectors for whatever data source you need? Well, the problem is each data source within need lots of boilerplate code that has to go in to get things to work. That brings a lot of maintenance and dependency issues that have to be maintained. If you're working with a native cluster on top of a standard Java-based cluster, that also requires you to have two different implementations of the connector. So that kind of doubles maintenance. And you might have a data source that is very highly specific. It's not something that other people might be interested in, or something that is for security reasons or whatever. You can't share that with the community. So, the maintenance then kind of falls on yourself to provide these connectors. So what the Arrow Flight connector brings to you, right out of the box, you can have a framework to securely connect to remote data sources using a standard protocol, exchanging standardized data. Working with Arrow data from a flight service to Presto, it's done very efficiently. So on the Java side, we have conversions done to convert Arrow record batch to standard Presto blocks and data pages. And on the native side, leverages VLOX Arrow bridge. So VLOX already was able to speak Arrow. So we're able to make use of that, and works very efficiently to bring in Arrow data into VLOX. And with this kind of framework, it allows you to easily add new data sources to Presto. It's just a matter of having your flight service be aware of new data sources, and Presto can then automatically connect to those without any changes to Presto. And that allows you to seamlessly work with a Java cluster or native Presto clusters. So you wouldn't need to do any different configuration. They can connect right away to your just the one flight service. And so obviously, and then you don't need to make a native connector, just your one connector that works with your flight service. So a little bit about the design of the Presto flight connector. There's a kind of a difference between the Java connector and the native connector. So we'll give a brief overview of what that is. Uh, Both of them have a flight client baked in. So that is what connects to your flight service and does all the data transfer. Now, the Java connector is really a base template, like I mentioned, for you to build your concrete implementation. And for you to do that, it requires you to define some commands, implement some abstract methods, and a lot of that is to allow the Presto coordinator to do metadata discovery with the flight service and make certain calls to get schemas and table names. The native connector is a little more simple. It is only designed to read data, so it doesn't do any of the metadata retrieval. So there isn't much you need to do to get a native connector working. The only thing is if you have a specific authentication method for your flight service, you can insert a plugin into the native connector, which will allow you to do specific authentication. So none of that is hard-coded. That part is left open. So I'll go over a little bit more details about the Java connector since it has a little more it's a little more involved to implement. Uh, the main thing you need to do is extend this base Arrow Flight client handler class, and that sort of wraps the flight client and allows you to do the interaction with your flight service. So there's 4 abstract methods in there that you need to implement. 2 of these are to define a flight descriptor, which is basically a command that you're going to be sending to your flight service. So it really just returns a command and that's it. The first one is to get a schema that translates to a get schema remote procedure call. And get flight info is the second one. Besides those, there's 2 other methods you need to implement. One is list schema names. The other is list tables. Both of these are to do metadata retrieval. It's sort of obvious by the name, but it's kind of left open on how these are implemented. However, probably the best way to do this within Flight is to define action RPC to provide a custom command, and the flight service would accept that action and return back a list of schemas or tables. So that's basically all that's required of the Java connector. Excuse me. So now I'll go over an example. Hopefully that'll make some of these interactions a little more clear. This example is part of the Java code base. So it's within the tests and what's used there. Basics of this is it's a simple flight service that has a producer that reads from a local H2 database that uses the Apache Arrow based JDBC adapter to read from the database and convert the data into Arrow record batches. So within the server, we define a couple messages, request and response. Both of these are JSON-based messages. So any request that comes into this flight service has this message, and it has different configurations depending on what the specific command is. And the response is when it responds with things like a list of schemas or tables. And like I mentioned, best way to do some of these is with actions. So that's what this producer has to handle requests for listing schemas or tables. Okay, so this diagram, we have our Presto cluster with the flight connector on the left, flight service, and our H2 database. The first thing that happens is metadata discovery. So with that, the coordinator calls the connector to get a list of schemas. That's then translated in the connector to an action that calls the flight service to do discovery. Then the flight service gets that, queries the database to get the schemas and packages that up in that response message, sends it back to the client within the connector. And the connector unpacks that into a list that it provides back to the coordinator. And the coordinator now has the list of schemas. It's basically the same sequence for listing tables as well. So now when it comes time to read data, it's done in two phases. The first phase is getting the flight info, which provides a couple things. One, a list of fields from whatever table you're trying to read, and a list of endpoints. And endpoint is something the flight service provides, which will allow you to connect to read a portion of a data. So the coordinator kicks us off with a call to the connector to get splits. The connector then starts off with this call to the flight service to get flight info. That queries the database to get the list of fields with whatever table is requested. And the flight service is, like I mentioned, responsible for putting together the list of endpoints. So it sort of depends on what the flight service does and what the data set it's working with. It can return one or many endpoints. So that flight info gets back into the flight connector, and that translates it to a list of arrow splits, which it sends to the coordinator. And the coordinator takes those splits and then can distribute those to available workers to begin reading data. So once a worker gets a split, it will call the connector to get the next page of data. The connector then takes the information from that arrow split, which contains an endpoint inside of it. It uses that to make a call to flight service to do get. That get then creates a JDBC result set in the database, and the flight service begins iterating over that result set and building arrow record batches.
Hey, Brian, there's a question. Can we do that one?
Sure. Yeah. Please, any questions?
Maybe Matt answered. Okay. Well,
Go ahead.
Hamid asks, is there any change in Apache Arrow supporting high availability, being able to resume if there's a communication failure? This means do not kill the query in the backend if there is a communication failure.
There's nothing directly built into the flight connector, so I think that would kind of depend on the actual flight service you have implemented, and you would probably need to implement a few things in the implementation to do appropriate retries. So yeah, not quite built in, but
Thanks. It looks like Matt also kind of answered as well. Thank you, Matt. The high
Okay.
availability for Aeroflight service is controlled by the underlying gRPC service infra that hosts the flight service. So good.
Oh,
All
okay.
right.
Are we good with the question?
I think we're good. Hamid,
Okay.
just chime in if you have more questions. All right, go ahead.
Okay, great. Um, right. So the flight service then starts streaming Arrow record batches to the client in the flight connector. Um, Each record batch is then translated to a number of blocks that builds up a data page for the worker. Then the worker is able to read that standard Presto page and return the query results. Okay, that's pretty much the whole sequence. So I'll just pause again for any questions if anybody has anything. Okay, well, I'll keep moving. Just a couple more things left. So I wanted to talk over some best practices you might keep in mind if you're doing your own implementation of a flight service and connector. Um, Probably the most important thing you need to be aware of is to tune your record batch size. Um, this is something that needs to be done within the flight service itself. Kind of depends on what data you're looking at. But it sort of becomes a trade-off of you want a big enough record batch size to minimize the number of calls made and do efficient conversions. But the bigger record batch size you have means the bigger uh, data page that ends up in Presto. So it uses more and more memory. So it's kind of a balance you need to tune. And a lot of times, what you might do is when you're defining your command within your flight service to request data, you would leave an option to configure different record batch sizes depending on what data is being read. Okay. There is some zero copy options you can do in your flight service when you're sending a stream. That can sort of help with things. One thing you want to keep in mind though, so it will zero copy a batch as it's being sent through the like gRCP transport. But when you're working on the next batch, you can't use that same one. You need to allocate a new batch for the next one you're working on while the one's being sent. So that's really kind of the best you can do. You can't get away with only making one single batch and reusing it. I mentioned before in the interactions, the Presto flight connector does make a call to get schema within the flight service. Now, when you're implementing a flight producer, Git schema has a default implementation to call get flight info and just extract the schema. But usually when you are getting the entire flight info, that takes a little bit more work than simply getting the schema. So you can kind of avoid that by making a separate call. So you have get flight info and one call and get schema, which is a little more simplified. And that's done in the example. So you can take a look and see how that's done. When you're defining the commands, uh, it's kind of nothing is hard-coded within the Presto flight connector to make the commands any certain way. It's really up to your flight service, how that's done and what fits your flight service the best. But the usual thing is to define a standard serialization format like a protobuf or JSON format. but there's no hard requirements when you're defining that. Um, There's also no default client timeout within the calls to flight. Presto has its own timeout, so that works. But depending on how your flight service is set up and what you're doing, you might want to in your implementation add some additional timeouts, maybe to certain calls or whatnot, to make sure that it responds in a reasonable amount of time. Okay. And finally, just to kind of summarize things, I have kind of a checklist of things that you would need to do to keep them, things you need to implement if you're making your own flight connector. So first thing, you can override your Arrow module. That allows you to inject your dependency classes within Presto. You would extend the Arrow plugin, which allows Presto to pick up your connector as a plugin. We talked a lot about the base Arrow Flight client handler. There's a number of abstract methods you need to implement. These are defining commands and methods for metadata retrieval. You can optionally extend the Arrow block builder. If you have specific data types in your data source that need to be handled differently than what is done by default in the conversion from Arrow to Presto. And this is also done in the example, so you can take a look and see how that block builder is overridden. And in your flight service, you need to just make sure you handle different commands that Presto is going to be issuing and implement get flight info and do get. For the native connector, much simpler. You just need to think about authentication, and if you have a specific authentication method, then plug in that to your connector. All right, that's all I have for the talk. I worked on this flight connector, but there was also many co-authors and people reviewing. So I want to give a big thanks to our IBM team and the co-authors of these PRs, and big thanks to the Presto community for helping out with everything. And any more questions? I'll be happy to take those.
Looks like there are a few. Thanks, Brian. Great presentation. Are there any plans for Presto to output results in the Apache Arrow format?
Yeah, so I think I've heard this before. This is if I understand correctly, it's not really related to the connector, this flight connector per se, but more of a way to and get results back in a different format.
Oh, he actually clarified to avoid the column to row conversion that Presto does in its REST API.
Right. So the REST API. Yeah, I mean, I think that sounds like a great idea. It would definitely be very efficient. So, yeah, I think that's something worth looking into. There's no concrete plans right now, but yeah, I've heard that request before, so it's definitely something I want to look into.
And I'll just add, obviously Presto is open source, right? So we welcome anybody to join and help build this stuff, right? So if this is something you're passionate about, Matt, raise a file it, right? And maybe you can help us figure out how to build it. I think that's really awesome when we get outside folks helping to build this. It's what makes the community a great community.
Yeah, definitely. And there's my GitHub handle out there. So any questions, feel free to hit me up on GitHub.
Cool. All right, folks, any more questions before we wrap up here? Sweet. All right, reminder, I did record this, so this will be up on the Presto Foundation YouTube channel. And also, I think it just automatically gets recorded on LinkedIn since we live streamed it. So a few places to catch the recording. Brian, thank you. This was really great. Awesome to see all this work. I'm excited to see where this goes. Thank you, everybody who joined. As a reminder, we have a bunch of events coming up, so feel free to join us for any or all of them, prestodb.io/events. And hopefully we will see you next time. Thanks, folks. Thanks, Brian.
Thank you. Bye, everyone.